A moment. Oh, okay. Hello, friends. Welcome to Java channel in Outer Event Fantastic. With me, Andrea Kraus, talking about Apache Camel. Andrea Kraus, please introduce yourself.
Hi, so my name is Klaus Ibsen. I'm from Denmark. I've been working a long time on Camel for over 10 years. And with me, we have Andrea.
Hey, boa noite, and I'm Andrea Cosentino, and I'm based in Italy, in Rome, and I'm the co-lead of Apache Camel with Klaus, working from Red Hat.
Yeah, me too.
Great. Please share screen and start the lecture.
Okay, so let me try that. So bear with me while we set it up.
Okay.
Hey, we can see everybody. So I'm the slide guy here, so I'm just gonna go in present mode and cross my fingers that everybody can see the screen now. So can I get a confirmation that everybody, you can see the screen now?
Yeah.
Okay, so welcome everybody to this talk about a Camel 3. Yeah, as we just introduced myself, here's some more information where you can find me on the internet. I have a blog, and you can also find me on Twitter and LinkedIn and other social media. And of course, the same for Andrea. You can find him as well there. So what we're going to talk about in this session is about the Camel. But first, let's talk about what is Camel. That's a really good question. And what do you use Camel for? So Camel is the Swiss knife of integration. It's one of the most active and developed project at Apache Software Foundation. At the bottom, you can see Git commit history from the many years, from the beginning in 2007 up till 2020. Camel comes with a lot of functionality, so it's possibly the giant Swiss knife. So here's bullet points what Camel brings to the table. Is a Java-based integration framework. It runs on many of the popular runtimes like Spring Boot and so on. It's based on enterprise integration patterns, which we'll cover in a moment. It comes with a lot of connectors, and you have a DSL, domain-specific language, where you can define your integration flows. Again, we'll see that in the demos, and Camel can integrate, well, everything or almost everything. So why Camel and what do you use it for? So Camel is used for integration or system integration. So we have system A and system B, and they need to be integrated, exchange data, and how to do that. That can actually become quite difficult because what protocols and transports do they speak? What are the data model? Is the communication synchronous or asynchronous? And how do you do with errors and failures? And how do we observe that everything is okay and many other things? And then you may consider, isn't this something that other people have thought about in the past? And do we have any, let's say, designs and guides for that? And yes, we have. In fact, that's what enterprise integration patterns is all about. It's a book with that same title. The authors of the book, Gregor Hobby and Bobby Wolf, were consultants that went out to clients and helped them in integrations. And they discovered these problems occurring over and over again from the same client to the next client. So what they did was to write down and take notes about them and how to solve them. And over time, they had so many notes that it actually became the idea of turning that into a formal book. So in this book, we have design patterns or recipes how to solve integration problems. And on the slide here, the book comes with 65 patterns, and on the slide you see some of them. the most famous ones are the content-based router. You can filter messages, you can route message dynamic and send to a number of recipients. You can split and aggregate and so on. So coming back to Camel. So what is Camel and what do we describe Camel as? It's an integration framework. So I like this picture to describe and say Camel is a toolbox that has ready-made tools for you as a developer to use to build your integrations. So the tools come with, hammers and saws and screwdrivers that you can use and know how to use, and other people know to use, because when you learn to use a hammer, other people can learn to use a hammer too, and so on. So it's the same tools you can use, and you can reuse them over again and again. And also Camel allows you to abstract away all the lower level details and focus on the higher level about these problems. So coming back to this integration between System A and System B, so where does Camel fit into the picture? Well, it fits between them. So Camel is the glue that connects System A and System B. And how do you do that? Well, the main focus on Camel, or what you see as an end user, is the Camel Routes. So a Camel Route is where you define how systems are integrated. And on the slide, we have some of the most basic routes in Camel. It's just from one system to another. So in this example, we're using a file system from file to a messaging system using Java JMS. So that's just from and to. And in Camel, you can define or write these routes in Java code or XML, for example. At the runtime, this will be the same from Camel point of view. So there's no, let's say, this is a typical question is that, in Camel, I can use Java or XML. Which one should I pick? Which one is faster? And so on. The answer is they're same. From Camel point of view, these are defining how the Camel runs, how to integrate things, but at runtime, it's the same model that gets executed. So let's take a look at an example, a little demo, and this with the demo got Bill Beers. Let me see if that works. So this is the widget and gadget example. This is from the Enterprise Integration Patterns book. And you can find this example on GitHub. There's a link on the bottom. The Camel examples are from Camel Examples GitHub repository. And it's called the Camel Example Artemis. We didn't get it, sorry, but this is because it uses ActiveMQ Artemis as the message program. So it was named like that. So I will exit the slides and go to my Visual Code. Before jumping in and showing some code, I just want to show you on the background. I have Artemis running. So this is just Apache ActiveMQ Artemis as a message program running locally on my computer. I just bootstrapped and started up, and that's running there. So in the code editor, so what you can do to run Camel, this is Camel alone standalone. It's not running in Spring Boot or Tomcat or some other app servers. Of course, you can do that, but to run Camel standalone. So this is just a main class. It comes with a main from Camel, Camel main. And what I do here is to, in the main class, I can create the Artemis component in Camel. And this is because I need to configure the Artemis JMS component to tell what is the connection to the message program. So this one will connect to the local host on port 61616, which is the default TCP port for Artemis. And I set up a few things for the program. Then I tell Camel, okay, I want to add a route, the widget route and the create order route. So there are two routes added to it. And then I run it. And then it runs standalone. So let's take a look at the widget and gadget routes. So I just scroll down here. So this is the route starting from a new order. Then I need to make a choice of when is widget. Then I log widget and send it to widget. Otherwise, I log to gadget and send it to gadget. So this is very high level in Camel. So this is, as you can see, there's no, these are very abstract, new order, what is that? That's an endpoint. And it is widget, what is that? That's a predicate. like the Boolean true false, was very high level. And here you can define the endpoints. So you can see the new order is a DMS endpoint on a queue called new order. The is widget is a predicate using XML XPath language to check if the order product equals widget. And widgets and gadgets are actually just queues on the same broker. So actually what we do is to consume messages from a queue called new order, then either sending that message to another, the same broker on a different queue, widget and gadget. Now, this is, from Camel point of view, this is perfect code where you can separate the definitions of the endpoints and predicates and so on from your routes from here on the bottom. But this is not a common approach that people use because you can inline those. So when you see the Camel examples from the website and what more, then this is not the typical way of doing it. But from Camel point of view, it doesn't really care. This is a more typical way that you look at the Camel examples where the endpoints are inlined. So it will basically just be shorter code, but here we say from a file system, source data, and then with a parameter saying, okay, leave the file alone, no operation. That means don't delete the file or something like that. So we keep the file. This is good for demos. And then we send it to the queue new order, and you can specify some parameters. And actually the tooling understands these parameters. So there's a plugin you can install it to Visual Code and other tools that can understand all these options you can configure. Because each Camel component has a lot of options you can set, and these are specific for each component, and these are for JMS. So you can see here there's like 60 or 70 options you can use that are very DMS specific. And if you go to the file component, then you have a different set of options you can choose related to files, whether you should delete the files or scan files recursively, and so on and so on. Anyway, if we want to run this one, we can run it from the terminal, maybe compile exit Java, and then we run this example. Oh shit, it's past midnight, so it would it's a snapshot release, so it downloads again. Okay, that's a new one to me. So I just ran this example before midnight, and now it's past midnight, so it starts downloading. I should run it in offline mode. Sorry for that. But anyway, okay, it boots up pretty fast, I assume. No, it has to download all these snapshot jars. But anyway, that's what's just one I want to see. What you will see if the example runs is Camel boot up, and then you can see it will pick up two files. The files are in the source data directory. We have an order for the widget and the second order for the gadget. And that's what we want to see. Let me try to just run it in offline mode. Now I have a mixed download. Let's see if that works actually. No. Damn. Okay. Let's go back to the slides. So moving on, then we'll talk about Camel 3. And for that, Andrea, take the floor.
Yep. With the Camel 3, the main, when we start the development of Camel 3, the main objective and the main focus that we have was to create an ecosystem. So we start from the Swiss knife of integration, and the main project, which is Camel, and we try to split what we have in the main repository in a multiple sub-projects. So the first one was Spring Boot. So now we have the Camel Spring Boot starters living in their own repository, and they have their own life cycle. So this is good for us. And on the OSGI side, we have the Camel Carafe project, which support the Carafe container. And so if you love OSGI, this is your project for sure, OSGI. And then the new project, the last added project in the ecosystem, so Camel K, which is the Camel on Kubernetes, OpenShift, and the cloud native, Enki native. mainly. And after that, we have Camel Quarkus. Quarkus is the last project in the Red Hat ecosystem, and we can call it the fast Java. So we will see this in the next slides. And the last project is Camel Kafka Connector, which is based on Kafka Connect, and we'll see this in the last slides with the demo. Okay. For the Camel releases, we choose for Camel 3 to use an approach like Java. So we will have 2 LTS during the year, so long-term support, and we hope, finger crossed, to have 3.4 as long-term support for Camel, based on supporting Java 8 and Java 11, and the other one will be 3.7 in December, supporting Java 11 for sure, and maybe Java 14. And this is an approach we choose because in this way we will be able to innovate in the middle release, and in this way we will be able to support stable version by backporting fixes and stuff related to stable code. So in this way we hope to have a better approach than what we had in Camel 2, which was around for 10 years before Camel 3. Okay, let's get back to Klaus.
Yeah. Okay, I'm trying to advance the slides. There's a delay. Okay, sorry, jumping ahead. So next topic is Camel K, as Andreas said. What is that? So Camel K is a lightweight integration platform that is born on Kubernetes with serverless superpowers. So Ka-ching, what's that? So it means that you can run Camel K on vanilla Kubernetes and also on OpenShift, but you get the best if you run Camel with a Knative powered cluster, and Knative can run on Kubernetes and OpenShift. Okay, but why and how? So Camel K is in the serverless space where you as a developer don't really want to care so much about runtimes, whether it's Spring Boot or Firefly or Tomcat or whatever under the sun. You just want to write some integration code, glue kind of things, and then just let the platform figure out how to run that. So this is what Camel K is all about. So it focuses on the Camel integration, the Camel routes. So the idea is that you just write a route file, and you can write in multiple languages. So not only Java and XML, but also Groovy and Kotlin and YAML and JavaScript and so on. And from this slide is just something that takes from a Telegram bot. So every time there's a chat, you can do some message transformation, send that message to a Kafka topic and receive the message from the same topic and call HTTP service or whatever you want to do. You have 300 Camel components, so there's a lot of, choices to do. And then you just say, I want to run this one. So there's a command line tool, Camel with a K, and you say Camel run and the name of the file. And then it's sent to the cluster, to Kubernetes. And then it figures out how to run that, and it runs. Okay, so that's the serverless part. If you kind of wanted to have an architecture of Camel at a high level and how this model works. So on one side, we have the developer environment, and on the other side, we have the cluster or the cloud or the remote cloud. So that cluster be running anywhere. It could be running on your local laptop. It could be on your premise in your company. So maybe your company has Kubernetes running, or it could be in a public cloud somewhere. It doesn't really matter. And then you can sit in your favorite editor, whether it's Visual Code or IntelliJ, Eclipse, or even in Notepad or whatever you do, write some code, and then take that command line tool and execute it. So what happens is that Kubernetes has a way of extending itself. They are called custom resource definition, CRD. So what we've done with Camel K is to create a integration custom resource. This is essentially, Camel. Then these custom resource definitions, they can be observed and managed by an operator. So there is a Camel K operator installed in the cluster that then reacts on when there are new custom resources from Camel, or if you update an existing ones. Then the operator has all the intelligence and smarts and whatnot to figure out what should be done. And, okay, you want to do this. Okay, let me run a container in a pod that has this. And it can do that really fast, sometimes, in seconds to redeploy and whatnot. Yes, next slide, if you want to go. Oh, sorry, there's a little lag on slide advance. Yes, okay, so coming back to what the key goals of Camel K was also to make deployment and redeployment really fast, because the existing model on containers model was, when you build a Docker image, it's immutable. So every time you had to do a code change or something like that, you had to do an entire rebuild of that Docker image. And these bars here show, for example, that they take longer time. So the red, yellow, and green ones are different approaches of building container images using Docker, depending on, let's say, the proximity of your Docker registry. Is it running locally close to you where you run it, or is it remote, or is something that take from a source code repository and build from the source code? They're all slow, but Camel K has a different smarts, and they can be really fast. Camel K is also available to easily install in Kubernetes from something called Operator Hub. So you can go to operatorhub.io, and you can find operators for different things, for databases, for Kafka, which is called the Streamsy project, and many other services. And here on the slide, you can see Camel K is there. So basically, that makes it easy to install Camel K in your cluster by just clicking a button. So to see Camel K in action, we actually just have a pre-recorded video, a basic one. So before playing the video, I just want to highlight on the top, we have the code, the Camel K code. So this is just a Java file. It could have used other language, but it's from a timer to a log. Then there's the terminal in the bottom. There's one that on the right-hand side, it shows the activity on the containers when they restart and so on. On the left-hand side, that's the terminal where I type new commands and so on. So let's go and play this demo. It's only a minute or so. So let's see what goes. So here I am in the terminal now. The Camel examples, Camel K comes with a number of examples in the exams directory. On the other terminal, I say kubectl get pods to watch them. So what you can see over there, if you can see it, there's a Camel K operator running. If I go back to my other terminal, I am going to say Camel version, just for you to see the version. So this is a RC1 release. It's somewhat old. And then I say Camel run and the name of the file, Java file, and / dev mode. That means it's a developer mode, so it will take the log and show it in the terminal. You can see that log is terminal. Now it runs already, timer. Hello, Camel K, it says in the log. Now I go and change the code to buy Camel K, and now I save the file. And as you can see, it immediately does a redeployment in the cluster. And you can see the pods on the other side is restarting. And this is, it doesn't matter if you're running cluster remote or something like that. It's the same development model, the same developer experience. Just write your code, save the file, and it's instant update. So that's pretty awesome. And what happens if I type a coding error, I'm missing semicolon, and you get the compile error. See what it is. Also, Camel supports different options, so I can make it run faster. So the timer is executing every 12 milliseconds instead of every second. So of course it runs much faster. Okay, so that was a quick demo of Camel K. Camel K is a very interesting topic if you're into cloud native and Kubernetes and all that kind of thing. So I just want to mention that on July the 9th, Nicola and Luca, which are core developers on Camel K, is going to present and talk about Camel K at DevNation Live. So just watch out for that space, DevNation Live website, or follow myself and Andreas blog, or Twitter or whatever you can find. We'll announce it more when you have more details about it. So I will continue and talk about the other great things happening in and around Quarkus, and in particular Camel Quarkus. And by the way, if you have any question, you type in the chat window, whatnot. Andrea and myself will come to the Q&A at the end of our presentation, and hopefully we have time for that and really talk about things. So Java has one particular problem, or there's a meme about it, that Java is slow, and also it has is a bit fat, or is a called density problem compared to others. So when you start to run application or microservice in the containers, or in the cloud, if you want to call it like that, on Kubernetes, then traditional Java cloud native Java stack is actually too fat still. For example, Spring Boot applications may take 150 megabytes or 200 megabytes just for REST service or whatnot. And compare that to alternatives in Node and Go and whatnot. Then years ago, there was actually a worry that that will be difficult to take your Java application and make them valid and on the container and cloud space, because if we could take a monolith and maybe turn that into a set of microservices, and then that explodes in terms of resource allocation that you needed on the cluster versus just having let's say a single node on premise. That will be a bit difficult solve. So what's happening in Java is that it has to get better on running on the cloud, and this is what Quarkus is trying to solve. And another problem with Java itself is that it has a scaling problem, in the sense that Java itself was built from a time where the idea was to bootstrap a Java JVM as a big process and keep it running for a long time, versus the modern approach is that you just kind of run only when there's a demand for it. So your application should be able to scale up quickly when there's some demand, service request, and then scale down when there's not so many requests coming in. There's no need for it. And even the last one is to scale to zero, because you don't want to run your process and being idle if there are no uses for them, especially around service providers in the public, where you pay by usage. So you want to be able to say, okay, I don't want to pay for if my service is not active and in need. So you should be able to scale to zero. And these are the main problems that Quarkus is trying to solve, at least for the container and cloud space. Quarkus are doing other things. And again, I will suggest that maybe you will have a session on Quarkus and get one of the Quarkus engineers to come and give a presentation on that, because it's a fantastic product. So what is Quarkus? If you go see their tagline, they call it a supersonic subatomic Java. And okay, that's a bit difficult, but it's something to Quarkus is from the atomic space. It's the smallest entity inside the atoms. But from our point of view, it's just fast Java. Okay. So if you see on their website, they say Quarkus allows to have help with reducing the footprint of Java, especially around memory. So here's an example with a REST service, and also a REST service with CRUD. So it's a Hibernate database doing insert, delete, and so on. So on the top, we have memory users. The gray one is the traditional one. And if you just run the traditional one with Quarkus instead, also on JVM mode. So just plain JVM, it can reduce memory usage. And if you're able to native compile, this is happening using something called Growl VM. This Quarkus has great integration with to make that much easier. Then you can really reduce the memory usage. But the compilation is actually time consuming, takes quite some time. So, we're talking about minutes and then gigabytes of memory to compile to native. So it's not something that is for everybody, but it's really is an interesting direction if you can start to get our application down in size. Recently, just prototype Quarkus on running on containers, and I had the basic REST application running. It was only 4 megabytes from that point of view. But also the second point is to be able to really have fast first response time. And by that mean this is part of the scaling thing. So you should be able to scale up quickly and be able to service the traffic and give it and return a response. So you should not cheat. Some Java applications or app servers are making themselves fast to start up, at least to say, yes, I'm ready. But when you get a request in, they still need to warm up and initialize all kind of things. So it takes time to handle that request and send back the response. So this timing here is actually based on, I called a service, there was no service, it has to start up, handle the traffic, and return back a response. And when I got the response, we stopped the clock and measured the time. And that's you can see on the slide here. And you can see this is really fast with native compilation. So that is something that can also work with serverless and functions. And just by using Quarkus itself, we're talking about less than a second now. And that's really awesome. And it's only getting better because this slide is, is not the latest. So things are getting faster. Okay, enough of that. Just a slide showing you this is actually Camel 3.1. So the latest one is 3.3 now. So it's a bit older. And also Quarkus is 1.4. As a release, this is 1.3. But anyway, so Camel was able to start up in 13 milliseconds, take up 16 megabyte of memory, and the binary was 68 megabyte at the time. We have dramatically reduced that in the latest release, 3.3 and 3.4 as well. So the binary size will go down. So everything is getting better. So let's see a couple of demos on that one. And we cheated, so I have pre-recorded one. And again, this is just a basic example of Camel and Quarkus together. So on the Camel Quarkus, on examples, you can find a number of examples. One is called timer to lock. And this is what I'm demonstrating here. I have, just cloned that repository and loaded the example in my editor. And again, it's a bit, what you'll notice in this demo is that it's a bit similar to what we did with Camel K as well, because Quarkus allows to start itself in a developer mode with the Quarkus dev Maven plugin. So Maven compiled Quarkus dev. Now it starts up, and Quarkus starts up the application, and it keeps running. So the timer will just say hello world every second. And now I change the source code and save the file. And again, as you saw with Camel K, it will do hot deployment. And now you can see it says spy world. So the Maven plugin from Quarkus is able to monitor your product and do hot deployment on the fly. It also works if you add new classes, new dependencies, whatnot. So that is sort of like the developer experience of Quarkus. And you can just run it in this mode and instantly get feedback while you code and, code errors and whatnot. Works with web browsers and so on. This is really, really awesome. And pay attention, this is standard Java. There's no Kubernetes or anything here. This is, just standard Java, so you can run it there. And again, the tooling understand these options. You can configure on Camel endpoints, control space. You can see the list, and you can get the Java doc of these with what they mean, each option, and so on. And what I'm going to see here is the tool also understands what other Camel components is available. And this is the list. So you see Amazon Web Service. You can see some CXF and Debezium, Elasticsearch, and FTP, Google, Hazelcast, and whatnot. So there's a long list of components you can use with Camel. Okay, so let's move on to that's actually quite interesting example. This one runs for a little longer, so have patience with me, but it's worthwhile. So if you want to start out doing Quarkus projects, you can go to the Quarkus.io website, and they have a start coding button. So if you use Spring Boot, it's similar to Start Spring.io. You can set up your dependencies, and you can search for them. So there's a list here, and they are called extensions in the world of Quarkus. So they have an extension for all kind of things, for Hibernate and messaging and whatnot, and cloud. So what I want to do is to create an application that have health checks. So I had the small Rye Health, which is a small library for health checks. And I need to find from metrics. So I'm filtering, finding the metrics. Then I need to add some Camel stuff. And Camel are in the bottom here, Camel integration, so the Camel core, the microprofile health and metrics. So this is the counterpart from Camel. So Camel integrates with the health checks and metrics from Quarkus using the microprofile specification. And the platform ACP allows Camel to integrate with the ATP server from Quarkus. So we use, what comes out of the box from Quarkus. So let's do that. And then you can click the blue button and it downloads zip files, and you can, extract that and open in your editor. And I'm a bit hipster, so I also use Visual Code. Don't normally use this editor so much. I use IntelliJ mostly for Camel maintenance, but just for demos. Then this one is actually quite handy. So what I've done here is to create a Camel route called my route, add the application code, the CDI annotation, so it's discovered automatically by Quarkus. Then I say from platform ACP/hello/camels. So every time we call that service, it calls Camel, and we can return the host name. So let's go to a terminal, and I can run this one with Java jar. So this is the big fat jar way. So I have compiled it ahead of time. So it starts up in 1.3 seconds on my about 4-year-old laptop. Camel is very fast, 76 milliseconds. And now I can call the service 8080. This is the standard Quarkus hello page. And I can say hello, this is from Quarkus saying hello. And now I can, of course, call Camel as well if I want. Hello, Camel. Camel runs on my old laptop. And it should come with, health checks. So the health check status is up, and you can drill down and see what Camel says and other things in the health check. If you have other things installed, and the metrics, you can get, JVM metrics and also Camel counters. So this is, Prometheus standard, so you can actually feed them into Grafana and other things, and you can see, nice dashboards if you have tools for that. So now I just call the service again. If you pay attention, it says before it says 1.0, now it says 2.0. So I call the service, so there's a Camel counter saying that this route was called twice. So now I have a shell script called print sum. I want to see how much the memory is resident set memory. So the application is actually using about 200 megabytes, 198. That's a bit too high. But the JVM wasn't tuned so much, but it's still quite high for just a Java mode for this application. But Java is taking up a lot of memory normally. And if you have 16 gigabytes in memory, I'll take a gigabyte just to run this little application. So, but still, it was quite high. So this one is actually the native compiler. I compiled it ahead of time. So 20 milliseconds to start it up. The Camel is 2 milliseconds, and I run the same example. It takes about 20 megabytes of memory. So not well, it's getting better in the future versions. And if I call it again, it's the same thing as we saw before. You can see it just like in JV. Now it's native compiled. This one is compiled for Mac OS If you run on Windows, it will be Windows exe file and so on. So what I'm doing now is to run 100 instances of the same application, but using different port numbers from 8000 to 8100. So I have a little script for that. Now that's 100 instances running immediately on my computer. And they take out 1.8 gigabyte of memory. So 18 megabyte each, right? So I can call any of these services from the port numbers from 8000 to whatever. I say 44, hello Camel. I can choose another number and so on. Now I say 96, and they call Camel again. Now I kill everyone. Now they're all dead. So I can't. This one isn't. Now I start them again. I go immediately back and I call this service. As you can see, I get a response. So that was pretty fast, So you were able to start up 100 instances of your application in a blink of an eye, and they were able to service a request immediately. That's pretty awesome with just by using Java and Camel and using Graal and Quarkus and do native compilation. Okay, these were the demos I wanted to talk about for Quarkus. So I will give the floor back to Andrea. He will give you a talk about Camel Kafka connectors.
Thanks, Klaus. So Camel Kafka connector is the latest project in the Camel ecosystem, and basically is based on the Kafka Connect framework. Next slide, please, Klaus.
Yes.
Okay. Yeah. Let's talk a bit about what is Apache Kafka first. So Kafka is known as a distributed streaming platform, or also a published subscribed messaging broker. And as Camel is an ecosystem, so there are multiple components in Apache Kafka: consumer API, producer API, Kafka Connect, Mirror Maker, and so on. And the most important part for Camel Kafka connector is the Kafka Connect framework. Next slide, please.
Yes, there's a delay.
Yeah. And
oops.
Yes. So yeah, no problem. Yeah, the Kafka Connect is basically a framework, and is used to integrate your Kafka with other system, and in particular external system. So through Kafka Connect, you are able to define source and sink connector to stream data in and out of Kafka brokers. So those connectors we are talking about are pluggable, so you can use them as already packaged, or you can also write your own custom connector. And the connectors are distributed and scalable by default, and they have automatic offset management, and also they support simple transformation and streaming and batch integration. And in the no problem. Basically, the when you want to connect from an external system and inject data in your Kafka broker, you will use a source connector. While if you want to get data from your Kafka broker and send this data to an external system, you will use a sink connector in that case. This is important because it's not always clear how to use the Kafka Connect and also the terminology. Okay, next slide. And what is Camel Kafka Connector? So basically it's a giant Kafka connector built on top of Apache Camel. And this was started as a proof of concept in Red Hat. And Red Hat donated the software to Apache Software Foundation in December 2019. And the basic idea is to reuse in a simple way what we already have in the Camel components as Kafka sink and source connectors. And there is a parallel between the concept of Camel consumer with the source connector and the Camel producer with the sink connector. So there are some kind of relation between these two projects and the concept behind them. Next slide. Okay. So what's the status of this project? So today we released the 0.2 release, and so it's really fresh. If you want to try it out, it's already available for downloading, both from Maven, and you have also a list of connector as packaged as zip and tar. And we are already working on the new release based on the last Camel, so Camel 3.3, and is already on the way because we are under EV development actually. So we will release the 0.3 probably this week, by the end of this week. So the connectors, as I said, are packaged as single entity, so you should be able to use just the connector for your own system, and by using the related components, so you will have available zip and tar. And we have two possible way of using the connector. One is to use the plugin path under your Kafka installation. This is something related to Kafka Connect. And the other way is to exporting the needed jar and all the stuff to your class path and use that directly. Next slide, please.
Yes, it's
Yeah.
there's a lag again.
Yeah.
That's amazing.
Okay, so this is the list of the extensively tested connectors, and we have already some example available for those connectors, and you will find them in the Camel Kafka connector examples, and also in the Camel Kafka connector repository under the integration test. And we are planning to add much more connectors to the extensively tested stuff. So I'm personally working on this, but also the other developers are focused on this one to make the getting started experience better.
Next slide, yeah.
Yeah.
Oh.
That's why life is beautiful.
Yeah.
Yeah. So now we will see a demo, and I will show you how to use the S3 source connector and SJMS2 sync connector. Basically, this was a demo on one of my personal repository, but the demo was moved to the Camel Kafka connector example repository after the first release, the 0.1. And basically what we will see is what happens when you load the file to your S3 bucket, and this file will be consumed by the Camel consumer related to S3 component and injected to the Kafka broker, and then this stuff will be moved to a JMS queue. Let's see the demo now, and it's a widget again, and it's pre-recorded. Yes. So before we go ahead with the demo, so basically with the Kafka Connect, the idea is to be able to use a connector without less code possible, and we are reusing this idea in the Camel Kafka connector project. So you should be able to use a connector just by specify some stuff and some options on a configuration file. As we see in the S3 configuration, you are specifying a connector class, a converter for the key, for the value of your message, obviously, and these are options related to Kafka Connect, and they are combined with option coming from Camel. So you will have your access key and your secret key to access your AWS account and your region. And this is more or less the approach you will have by using the Camel Kafka connector. So in the example repository, you will find more or less just configuration file.
Yeah, it's coming.
Yeah.
Seems like it's getting slower and slower.
Yes. Okay.
Let's play the demo.
Yep. Okay, so this is the repository where the demo was placed. So I already have the Kafka instance running, and also on the other side I have also an Artemis running for the JMS queue. So in Artemis we have the MyQueue already set, and in S3 we have the Camel Kafka connector bucket already there. So to run the demo, we have a configuration file as we see in the last slide. So we are specifying from where we want to pull the file. On the other side, we have the JMS connector, and so basically is the same, just this is a sync connector, so you are configuring something different, and it's based on the SJMS2 component. Okay, so now we should be able to run the demo. So in this case, I'm going to check out a branch with the real credential. We are running the build, so we will have a package with all the needed stuff. And we export in this case to the class path, and we run the connect standalone with the basic properties, and we are pointing to the S3 configuration. On the other side, we are doing the same for the JMS connector and for the sync connector, and again we are pointing the configuration of the JMS component. Okay. Both of them are running, so we have the source connector and the sync connector running. And now we need to load our file to the S3 bucket, to the Camel Kafka connector bucket in particular. This file contains just a string, and I'm showing this is the element, the text, and contains a hello from Camel Kafka connector. We are loading the file, in this case on the S3 bucket. Is already there, so this will be consumed and deleted, and it happens really fast. And on the other side we have the MyQueue, which contains now just one message, and is the one coming from Kafka, containing the message coming in from the S3 bucket. So if we browse the queue, we will see that the message contains exactly that string. So yes, this is the message ID, and it contains hello from Camel Kafka connector. Okay, this is more or less the demo and how the connector works. So in the middle there is Kafka, and on the other, on the two sides, there is Camel. Okay, so this was the demo. There are other examples in the Camel Kafka connector example repository. Yes, and let's get back to Klaus for the roadmap.
Yes, so before we go to Q&A and so on, Andrea and myself just wanted to give you just an idea what's coming around the corner on the most important projects. So Camel itself is the 3.4 release, which is the first long-term support release, which is what we recommend for running in production. So you'll get critical bug fixes and securities and whatnot. The to-do list is to upgrade to Spring Boot, the latest one. It just came out recently. there's something called the endpoint DSL, which actually allows you to define your camel routes in a more type-safe way for endpoints in particular. So you use a Java Fluent Builder style. We had some issues there and some things we wanted to improve. Actually, those has actually been implemented. There's also a thing coming, something called a supervising route controller. It's actually a way of starting up your Camel applications and take care if some of the routes is not able to start up and be able to try to restart them with backoff and other kind of things. As opposed to today, where Camel kind of runs in a fail fast mode. So if some of the things fail to start up, Camel will also fail to start up. But with the supervising, you can actually mitigate that and tell Camel, okay, that's not a problem. I will just, start up anyways, and if I will just restart these routes in the background. So you have more options there. There's some ways to configure health checks in an easier way. And of course, the most important thing is also to do the last hardening and bug fixes for that release. Next slide. Sorry for that. This slide takes. We are using Google Slides, so Google is a slow company. So Camel K. So we also have a roadmap for that. Of course, the biggest goal is to support the latest Camel release, the LTS release for that one as well. Also, Quarkus as an integration runtime. It actually is already implemented, but there are a few other things we need to do. So basically, when you run Camel K, you can actually tell it, okay, I want to run Camel K, but in Quarkus mode. So it actually bootstrap your Java application using Quarkus and Camel, as opposed to just using Camel. Camel K is, working together with a product called Knative. So Knative itself is not 1.0 yet, but it's on the way to become that one, and we're following that. So when that comes 1.0, we want to have Camel K as 1.0 as well. There are a lot of other things that we are working on to have better IDE support for, in particular, because Camel K allows to define camel routes in many different languages. And if you're just using XML or YAML or Groovy, whatnot, you will like the tooling to be able to assist you. And actually, even for a Java one, you don't need to have a full product set up like a traditional one where you have a main and POM file, a Gradle build file, and you have many folders and whatnot. Because Camel K allows to run your Camel application just by a single file, a Java file. So you can actually open your Visual Code just by opening that Java file without having any Maven or whatnot. But the tooling itself inside needs to understand this is Java and I need to compile, and we have Maven dependencies, or we have dependencies anyway. So the tooling needs some plugins for that, and this is where we're working on. The testing side for Camel K, there's something called JAX. This is we'll talk more about that in the future. And again, I have to point to the webinar that is hosted on July 9th by Luca and Nikolai, where they will probably give more information about this one. But a very exciting project. And moving on to the next one. Again, slide takes a little while. So Quarkus itself, yes. So what we are waiting for is that when Camel comes with 300 components or more or less, and Quarkus is about 200 or so has been ported as extensions, but we would like to continue port them. It's a case by case. There's still some optimization we can do to make Camel and Quarkus run a bit faster, but step by step. But it's really awesome what it is today. Quarkus 1.5 comes out next month or end of next month. And we want to upgrade to that one and be on GA as well. And now we should come to the roadmap for Camel Kafka connectors, which Andrea can talk about.
Yeah. So, okay. So as I said, we just released today the 0.2 release, which got the support for Camel 3.2 and the the connectors in the project are auto-generated, starting from the components that we have in Camel. So there is a one by one mapping, and we have also the auto-generated docs. So on the website you will find the documentation for both source connector and seed connectors related to each single components. And the 0.3 release is already on its way, and today I bumped to the Camel 3.3 version, the Camel Kafka connector project, and so we have already available new connectors related to the new component introduced in Camel 3.3. And basically the idea is to release a version. We still don't know what version. So the actually the roadmap is 0.4, and this will be based on the first long-term support release of Camel, so 3.4, and we are continuing to improve the project there, and you are welcome to contribute to all the project of the ecosystem if you want. And there is a nice contributor guide on the Camel website, so you are welcome to contribute to the community.
Yes, thank you. And speaking of that, where can you find more material? There's a lot of information. Of course, you can go to the Camel website itself, camelapache.org, find information for each sub-project. You can find it on GitHub, Apache/Camel, and all the different projects are there as well. But, for these videos, if you want to play them again or see them again, they're on YouTube. Also, the one I did with the 100 camels, there's one that is a bit longer, and Bill explained. The second link is quite interesting. The Kafka one, we have a rather long one for 25 minutes with a different demo than Andrea, the one that Andrea did. And of course, I want to highlight that you can find the examples of Camel and Kafka connector cells on GitHub. And we also have for Spring Boot and so on. So let's go for Q&A, and I will have to stop the screen share here so we can see the chat window. And by the way, if you're on GitHub and kind of like Camel a bit, then you're of course welcome to give it a little star. Okay, so I'll exit this one and stop screen sharing, and then we can see all the questions here.
Yes, three question. This question.
Yes. So Leonardo asks, is there any dashboard to monitoring metrics of routing misses or alert according any situation? That's a really good question. So I will say yes, there are some tools for that, but but they are not from Apache Camel itself. And that's the message is Camel is just focusing on being this library or integration framework. So additional management and monitoring tooling and whatnot, this is out of the scope from the Camel product itself. So you can find third-party ones. There are some in, let's say, the open source communities. There's something called Hot.io, which can kind of visualize and show metrics and whatnot. But you can also find it from, let's say, a bigger one from Grafana and Prometheus and these kind of things. And especially on Kubernetes, there are some things for that. And one of the demos I had with the Quarkus things, with the health checks and metrics, Camel can just export this information to your centralized management tools, and you can see it from there. So definitely there's something for that.
Yeah. If I can add something, there is multiple components in Camel related to metrics. So you can use Camel metrics or Camel micrometers, or we have multiple of them. And obviously this data can be scraped by Prometheus or whatever you want. And obviously after that you can use Grafana, and you can do whatever you want with the data. But again, as Klaus said, this is something out of scope probably for Camel. This is something different.
Yeah.
Yeah.
Another question is how Camel works with the saga pattern is being used in. Can I call another route to my message if the first one fails? So yes. So the saga pattern, that's related to transactions, but in the absence of a real transaction orchestration manager that know from the past with the JTA specification. So if you in the past was running on Java E application server, you had transaction support that supported JMS and JWC and a few other protocols. They couldn't kind of do this transaction out of the box, but when you start to go to distributed systems and microservice and whatnot, then you don't have these protocols anymore. And then there's the saga pattern that kind of is a solution for that. So Camel has in the Camel routes you can actually use Saga. So there's actually an enterprise integration pattern called Saga, so you can use that one in there, and you can plug in a different implementation of that. It's my understanding that there's a specification for that hosted by, I think it's Eclipse Software Foundation that has this one, and then there is a reference implementation that we integrate with, use for testing. And then you can use that one, and it can do these compensations. So if you can say, for example, commit to this one, and the second one is failing, then you can do a compensation, try to undo the first one. This is some of the process that Saga is doing, and Saga is orchestrating all of that. So to answer the question, yes, and there are an example of that as well coming with Camel. But I have to stress that the quality and the maturity of the Saga orchestration manager and all these kind of things, that's outside of Camel, because these are these third-party products that are doing that. So take a look at the different implementation and pick and choose the right one. Okay. A good old one. What is the difference between Camel and Spring integration? Actually, they are very similar in the sense, because both of them are integration frameworks, so integration libraries, and small in the sense that, and they also based on the idea from the enterprise integration patterns book. Camel is the best one, I would say. Of course, I'm biased, but it has the huge community. It has the most diverse number of different users. It's used the most in the world. It has different DSLs for Java, XML, whatever. It's the most diverse or different ecosystem. Now we saw here with Camel 3, there's 6 different sub-products: Camel K, Quarkus, Kafka connectors, and all that kind of things. Spring integration, to my understanding, is that it's a smaller thing. It's kind of thing of the Spring. It has its fame from Spring, right? So if it was not named Spring integration, nobody was really paying attention to it. And it has a lot less components of connectors. So
yeah. Also, to my understanding, they don't have a concrete implementation of the enterprise integration pattern. So it's something different, and so yes, it's another integration framework, but with something less than what Camel has.
Yes, but don't take our word for it. If you are new to this one, try it out. Try Spring integration or try Camel, and pick and choose. And also, if you somehow end up doing some stuff in Spring integration and then later want to use Camel, and then Camel can actually integrate with Spring integration. We do have components for that one. Next question. So, hi Klaus. Hi. Recently, I'm finished Camel in Action second book. Do you have an idea about a date for third version? So if you take the timeline between the first and the second book, that was 7 years. So that gives you a clue when the third one will come out. I know, a bit kidding, but I do think now that Camel 3 has been released, with, as you can see, all these great new products coming around, there's so many different things to talk about. And, so Camel and new books. And new books is certainly would be really awesome. But maybe instead of having one giant big booklet, 1,000 pages that Camel in Action is, maybe we'll have 2 or 3 different books, but more smaller. One is focused on Camel itself, another one will be focused on Camel K, and a certain one might be focused on Kafka, Quarkus, or something like that. So different, topics for books, but certainly. But as today, we have not started writing. And also, you don't become a millionaire writing a book, so don't do it for money. It's a lot of work. It's just a way of getting validation of the product. If the open source product has books and whatnot, especially in the beginning, that was really important. Now, yeah, we don't know, but anybody is of course welcome to write books. Are there more questions? Can you talk about how and where to run Camel JS? Do you mean JavaScript? I can start a bit, and Andrea may have some comments as well. So if you take the traditional Camel product, or the Camel main product, or Camel 3, if you want to call it, there was a Camel script component that integrates with the JavaScripting API, but that one is deprecated and also being removed from future Java version itself. It's also shown to be sort of like a security vulnerability problem, because using that one that allows people to attack your JVM application using the scripting vulnerability itself. And so it has been removed in Camel 3 support for JavaScript, and that means from calling some scripting you write in JavaScript. But to define Camel routes or writing Camel application in JavaScript, that was never the original goal of Camel. It was to be a Java language. But since Camel K came around, it changed the story a bit, because you can write smaller Camel routes in JavaScript now. So Camel K has support for writing Camel routes in JavaScript and using fully JavaScript. So it will kind of find a home there.
Yeah. So yes, you can find this stuff in Camel K, and in particular in the Camel K runtime repository. So there we have support for multiple languages. So you have JavaScript, you have Groovy, Kotlin, and a lot of them, and YAML too. And so basically, to use something different from the Java DSL and the XML DSL, you have to look at Camel K actually.
And I can probably also add that, so in the Quarkus product itself and Graal VM, they are actually also interested in having, support for JavaScript now that, it's kind of kicked out of the Java JVM itself. And they are talking about, having different JavaScript engine there. I think it's called Truffle or something like that. But, how to get that to native compilation with Graal is also another huge step to get there. So, but there's something going on in that space. So I will say maybe in the future, in light of what they do and what comes in from Quarkus itself, then maybe, Camel Quarkus becomes a way of also using JavaScript as a way of writing Quarkus applications or Camel routes or whatnot. So something is going on, but they are probably mostly on Camel K and Camel Quarkus from Camel point of view. Okay, yes, other.
Good question.
Andrea, do you want to take that?
Yeah. So it depends on your application. So for what concern EAP, there is the Wildfly Camel project, which is outside of the Apache Camel ecosystem, but is based on Camel and is maintained and then by multiple developers. And in my opinion, actually probably the best option between these three is Spring Boot. And I'm saying this based on my experience. But I have to say that the graph support is still something. I mean, it depends really on the application other, and what are the requirements of your application.
Absolutely. And also this question, it seems like there's only 3 choices, right? But in reality, you have many more. You can run Camel standalone, you can run it on Quarkus now, other app servers and whatnot. So it's totally up to you. That also shows the flexibility and agility of Camel, that it's not tied to a specific only. You can only run on Java EE, etc. But you can run it kind of anywhere. That's at least what we're trying to do. So you can pick and choose. But also, Spring Boot is a different beast than the other 2 guys, because it's not a multi-host app server. Spring Boot is kind of like a single app kind of thing, whereas EAP is a traditional app server, and Carafe itself is also an OSGI app server. So EAP and Carafe is kind of like a monolith app server, but you can deploy many apps inside it and undeploy them and manage them, whereas Spring Boot is a single entity. So that's a different thing. Spring Boot, of course, has become quite very popular in recent times, but that's, I think, in my experience, is mostly around the Spring framework, the Spring brand, but also in their ease of use of the developer experience. As a developer, you have a single place to go to, and they have documentation guides, but also these just to add a new feature, you just kind of added dependencies, so you don't need to install too much, and they have auto configuration and so on. But from Camel point of view, it's your choice. We run where you want to run it, and Camel is happy to run on any of these 3. Are there more questions? When comparing to other tools like IBM Integration Broker, what will be a main advantage of Camel over these tools? Okay, so that was probably so we had the question between Camel and Spring integration. This is kind of like comparing the fruits, apple to apple, or the same thing. But IBM Integration Broker, that's a different beast than Camel, because that's an entire integration platform or solution. From, I would say, even IBM now quite Red Hat, but it was closed source, kind of evil software. Big heavy things, versus Camel is just an open source for the developers, community-oriented project. So this is David against Goliath. But David, coming from Camel, he sort of gains a lot of popularity and a lot of usage. So I will say, with open source becoming so prevalent and getting, becoming a first choice for many organizations and companies, and want to see inside, and people want to be able to participate, then I think Camel is the future, and IBM Integration Broker is becoming legacy. Okay, and of course the cloud is changing a lot, right? So a big monolithic apps integration platform app server kind of thing is a different beast on the cloud. So if you want to be, you have to be agile and small and nimble to be able to adapt and run in the cloud, and that's where we're heading with Camel. So now we get to the I've been struggling questions. Then it's time to okay. I've been struggling a while ago to build unit integration test with a Camel Spring Boot product. What do you guys recommend for the matter? Okay. So I'll say something. Maybe Andreas can also give some pointers. But take a look at the, let's say, the Camel Spring Boot example. Some of them comes with tests included, so you can kind of see how it tests itself. Also, I would say the website has some documentation on testing, but I'll have to admit that it's not super. This is something that we need to flesh out and do better. I'll also then give a shout out to my book, the Camel Action book. There's a full testing chapter. I think it's 50 pages or so. It talks about how to test on different runtimes, and particularly also Spring Boot. And it differentiates between unit testing and also integration testing, which are not the same thing. And for integration testing, it comes with a recommendation for, let's say, other libraries you can use to help do integration tests. And I just want to mention one of these libraries. This is a different category. It's called the Citrix framework. And why I'm saying that, because the Citrix framework is, the guys in that product is working on this, I mentioned just briefly, something called YAX. This is behavior-driven development testing for the cloud. And, this is something that we will talk about more in the future. So this is also a very interesting product. Andrea, do we have any?
Yeah, my suggestion is to have a look also to the Camel test container stuff, because usually one of the complex situation is where you have to, spin up something and test against a container or stuff like that. Now you can do that directly in Camel with the Camel test container. So you will be able to run your Docker container directly and use whatever is the pointer address or whatever it is directly in the test. So this is one way, of having a real external system or third-party system, and this is something usable in case, for example, of database or NoSQL or whatever you need. And for integration testing is a good option.
Absolutely, that was really good recommendation. We are starting to migrate some of the, let's say, Camel is a 13 years old project, and some of the integration tests or in unit tests we do have is actually embedding these databases and whatnot in memory and then running them, and then that's actually getting a little complicated to maintain over time. MongoDB and other things, and then test containers is a breeze now, and I love that one. So we are migrating more and more of these to use test container when possible. And also there's these mock libraries, Mockito and sort of things like that. I have a hate and love relationship to them, because they can be a nice thing to use where you kind of just stop out things and you can use these Mockito things to simulate other things, but they tend to become very internalized and low level, so you have to specify the call in this order they come and what they return to simulate that. And that's really a pain when you start to refactor things that are internal changes. For example, in Camel, and now these Mockito tests start to fail because Camel calls something else inside itself, and so you get frustrated by that. But this is also an option for doing. Okay, next question, if there's anyone. Oh, that's a good one. Is there a drag and drop tool or something in roadmap that can generate Camel routes for messaging processing? Now we're coming back to this about the questions with the monitoring, alerting, and so on. There's nothing out of the box from Camel. Camel is just a library. There are some visual editors that has drag and drop. In particular, there was Eclipse tooling from Red Hat or JBoss Apache Camel tools that can do drag and drop. So you have a command palette over here with the patterns and the components. You drag them on the canvas and you can connect things, and in a properties panel you can set options and so on. That tool is still there today, and it is a desktop Eclipse tool, and it generates or works only with the XML DSL in Camel. And I have to say that this tool is becoming, let's say, less maintained over the time, because we are moving to plugins for Visual Code, Eclipse K, and other tools that are more modern, web-based tooling, and so on. So there will be new set of tools for the future, but that old tools is still there. And then I'll also say that the experience is that you may want in the beginning to have these visual drag and drop things, but then when you get more familiar with Camel, then people, what we've seen is that they switch out and don't use that visual editor anymore. They start just to use the direct code editor in Camel, and there's actually quite support for that with the what you saw in the demos with the control space. You can see all the options and so on, and that's what people do over time. So they might start with the drag and drop thing and then switch to just eating source code. Andrea, do you have any comments on that one?
Yeah. I believe visual editor is a thing, but once you have to, once you have particular situation or complex development, it's something you may use to just write in the beginning of the application. So it's something nice and probably is funny too, but when you have production code or stuff like that, it's not an option.
Yeah, that's true. And also, is to build a full-blown visual drag and drop tool is actually takes quite a lot of effort, especially for Eclipse and so on. That's why, let's say, in the open source spare time, nobody really does it. And it took JBoss or Red Hat to sponsor people to do that. Okay, are there more questions or are we over time? I'm not sure. Anybody has to stop us. Otherwise we just have to go to bed. And I'm having fun still. Is there a plan for a visual editor of the routes? Oh, that was kind of like the same questions. Again, yes, there are coming some more modern tools for, especially around the cloud and so on. And I also have to say, if you are in the different space where you might not be a developer per se, but more like what is coined as a citizen user or citizen integrator, maybe a business line of person, something that maybe is accounting or something. Then there's a product called Synthesis, which is an upstream product for a web-based Camel integration tools. So you could do everything in web browser. You just do this visual editing, but it's not as much for drag and drop, but it's sort of like driven still using visuals and in a GUI way. So you can say if you start from something, you can configure it, but it has a nice, let's say, hand-holding. So for example, to connect to a database, it allows you to type in your credentials and the connection URL to the database and validate that this works. You can click a button and it actually connects to the database. And then if you need to, let's say, query the database to find out some data, you can show you a table with a list of all the table names. So you can kind of go step by step and help you to build your integration. And what I'm saying is that under the hood in Synthesis, all becomes Camel at runtime. So it's kind of like a Camel, smart Camel editor. And if I put on my hat from Red Hat, then we have a product. You can use this one. It's called Fuse. Fuse Online is the name for it. The name is a bit misleading because you can actually have this product also running on your own computers. You don't have to use it sort of like a public cloud thing, but it's a fully web-based tooling for that one.
Synthesis is also a growing community, so it's a good project to look at. And actually, is the number of connectors and components supported is not as the main Camel, but there are already 40 components there. Basically, you have the predefined action, so you can specify option and whatever it is, but the action are predefined. So send this message to a JMS queue or send a message to a Slack channel or whatever it is without touching code. So it's just everything is done to a user interface.
Yes. And if I add to that, then what Andreas, when he says an action, it means that if you take a Camel component, it might be very generic and very broad. It can do 100 things. For example, if you take a social media component for Salesforce, for example, it can do insert contacts, it can update, it can query something, you get a report, it can do, the Salesforce API is huge. You have 200 or 300 different actions. So to not overburden the users in Synthesis or Fuse Online, you can actually sort of pre-configure these components to a specific action or set of actions. And then that world becomes much more simpler, and you have less options to configure, and you can give them new names. So from the end user's point of view that are using this tool, don't know that under the hood that this Salesforce component can do 300 different things, because all he or she is focusing on is to update an account, because that's the action it can do. So that's really awesome. And also the hybrid model of Fuse Synthesis is that you can actually allow a Java developer or a Camel developer to build these connections and other things that they are calling extensions, and they can install them inside the synthesis, and then that became available for the citizen users to use. So you can kind of, have them work together. Okay. It is, as another question here from Melina, is it common to find people interested in migrating from ESP solution as WSO2 or MuleSoft to Camel? Yes, it's very common. And we see that all the time. And if you see some of these vendors, they may also see that they see, some migrating from Camel, but we see a lot of migrating from, let's say, also from big vendor software that are commercialized, closed software and big and heavy, and they're moving towards lighter alternatives. And Camel is particular in that space, Mule as well, and WSO2 as well. But Camel is the true 100% open source hosted project that are in Apache Software Foundation. The other ones are actually a single vendor company. But we're seeing that, and we are, replacing Mule and whatnot. So it's quite common to see. This is sort of like the same question in the sense, how is Camel adoption in enterprise environment so far? It's getting better and better, if I can say that. It certainly is. Camel is gaining momentum around the world. Even so, because Camel has been around for so many years. When I started with Camel 13, 14 years ago, open source was certainly not the first choice. Open source was just, kind of in the beginning, we had maybe Tomcat and a few other things that became a thing that you're allowed to use. But over time, it, gradually grows, right? And Camel was the success of Camel is that it was so flexible and adaptive, so it can actually work together with, commercial vendor software. So you can actually run Camel on IBM WebSphere or WebLogic and other app servers. Whereas, for example, some of the other alternatives in the open source world could not, like Mule. It was kind of standalone. But all we're seeing is a moving to trend towards, more and more open source across all the board. Whether you run on-premise, on the cloud, and so on. What about you, Andre? You must have seen some of that as well.
Yeah, from my perspective, there's a lot of adoption, and even in terms of my daily job, I see new customers every day. So also we are seeing interesting in the new sub project from entity we didn't see before. So we got single developers, but also sometimes people from organization asking from new features in the upstream project, and sometimes we have also a lot of contributions from organization. So for example, in Camel 3 and also in Camel 2 we have the Camel Pulsar component that was contributed and donated by an organization, and it was a good experience, and they also wrote a blog post about this and about how it was easy for them to contribute to Camel, and how the community was able to listen and suggesting and reviewing the code. So
yes, that's really we've seen a huge uptake on community activities. And I have to say, okay, there's also the tip of the iceberg. You can see on the front side of the community, what activities are on the mailing list and JIRAs and whatnot, because still I think there's still maybe a huge number of people that are silent users, right? So they start using it. Maybe they have restriction in their organization to actually go and engage in communities because they don't want to have that message out that this company is using that product. Or certainly if they have to do code contribution, that might have a barrier as well. But maybe they're starting to open up a bit more because this has become very popular. And certainly what I want to say is that GitHub was a game changer in the sense that it's so much easier now for people to get into a community because that's a one-stop, easy to browse the code, you do PRs and review code and whatnot across many products. And then if you're on GitHub, then the product is more visible, I would say. Okay, more Q&A, or are we getting close to the? Okay, there's the question about JAX. Yeah, take a look at JAX. Certainly, it's really looking very promising. I have to say we have a blessing, very good news or bad news. The guy that is the creator of JAX, Christopher, is also one of the main creator of the Citrus framework. Has recently became a father, so he's a bit more absent from his computer now. This is something also Andrea has experienced recently.
Yeah. For him, it was the second time. For myself, it's the first, but it's the same. So yeah, busy time. So.
Yeah, but take a look at JAX. This is really a very promising and great project. Okay, so sorry for running over it so much.
No more questions. Thank you for lecture. I very good. You want to say some word final?
Oh, I think we said so much, but have fun. Try Camel if you have the opportunity. If not, you have the opportunity to get your fingers dirty by trying Camel. Maybe take a look at one of these examples again from the YouTube videos, or read the blog post or whatnot, or just remember there's something called Camel for integration, and maybe in the future you'll get it around because it's been around for 13 years and might be around for another 13 years or so. Andrea, anything to say?
Yeah, thanks for inviting us, and it was a nice experience. And join the community because open source is a winning choice actually. So Camel is waiting for you.
Oh, so great! Thank you so much for lecturing. Thank you.
Thanks.
Thanks.
Bye-bye.
Bye.
Oh,
Cheers.
good night.
Good night
Great.
for us. Cheers.